Thank you for having me. I'm an assistant professor at Lawrence Technological University, and I'm going to go through this very quick because I know there is no time on this. Let me move on here. Don't worry about this. So why we need to use BIM in the construction industry? This is the question. And why it's because the construction industry up to today, has the nation's highest share of fatalities at roughly 20% every year, even though it counts for roughly only 4% of the workforce. The industry non-fatal injuries rates are again 70% higher than other industries. In 2018 alone, the industry recorded more than 1,000 fatalities on only construction workplaces, 80,700 injuries, and approximately 350,000 damages to underground utilities. And here's over the years, here is the red bars represent the share of fatalities, and blue bars represent the share or the construction employment out of the overall workforce. So we are, the construction industry, facing a very high rates of fatalities, and because of that, that's mean we need to have, there's a lot of opportunities for improvement when it's come to construction safety and safety management. Before I start with BIM, let me talk a little bit about construction safety and quality. Since this is a quality chapter here. Quality, there's a relationship, a positive relationship between safety and quality performance. And researchers concluded that rework and schedule delays are critical components when it comes to project manager, and these affecting even the incidents as well. So there's some kind of overlap between safety and quality. I just published this article last year. It's about quality and safety management practices and how they are really, there's an overlap. So same quality management tools, we can use them to manage safety, and it seems it's very useful and very applicable. So if you guys, any one of you need this article, please just shoot me an email. I will be more than happy to send it to you. Let's go about BIM. So how we can use BIM in construction safety? There are a lot of researchers right now working on this. We are trying to use BIM because it's a good communication tool. And again, if we communicate better about safety and safety issues, safety hazards, it's expected that we can reduce the overall fatal and non-fatal injuries on construction workplaces. So one of the direction is to incorporate OSHA regulations in BIM models to identify potential hazards. Studies have shown, again, studies showing, but we're still in progress, showing encouraging results in applying OSHA to come up with to identify unsafe conditions on a job site. For example, this is a 3D model for demonstration purposes. And if you look at this 3D model, everything is good. But as soon as you move the guardrails, the permanent guardrails, handrails, and walls in the 3D model, the hazards associated with the floor opening and leading edges during the construction phase are visible right now. So right now, we look at this and we can identify the hazards over there, the fall hazards. But the question is how we can use BIM to identify all the hazards within this one. One of the key problems associated with applying the OSHA regulations with BIM models is linking the text-based rules within the OSHA regulation to the BIM models. And the typical workflow to convert narrative regulation to safety rules that could be used for linking to BIM is this 4 steps. So first thing, we need to get the narrative out of the OSHA regulations. Then these narratives, try to convert them to rule sets, like as you see here in the third section here. And then when you have this rule set, we can linking BIM to them, linking BIM to them. And if we apply this method in the previous model very quickly, we can get something like this. okay? And this is based on the rules we're gonna set. Basically, the rules are here. The identification will be based on the following regulation. All areas 6 feet above the floor slab and areas within 15 foot or feet of floor opening. These are hazardous. There's a potential for falling out of these edges. So we can identify 3 areas based on this criteria: red, yellow, and green, and we can provide some kind of tool that safety managers, or even construction manager can use to say, okay, this is a red area. We have to have a guardrail system. And even if this project is a prefabricated project, we can use this to ask whoever going to prefabricate the work to include the guardrails on this area around the building, to ensure that as soon as we have the components of the building, we're going to have the guardrails at the same time. So this is just a quick overview about the potential. I believe the industry and the scholars are still working on this, but this could be something we all utilize in a very near future.